Okay, so we have a lamp of luminous intensity 500 candela suspended 2 meters above a working surface, and we've got to calculate the illuminance. And then the second part of the question is that the lamp is moved 3 meters above the working area, and we have to do a separate calculation for that. And the formula that we use is E equals I over D squared, and we just put our values in. The I is the luminous intensity of 500 candela, and the distance squared in this instance is 2 meters squared, and if we do a calculation for that, it is 125 lux. That's the first part of the question. And the second part of the question, exactly the same formula, only this time the distance changes, so it's still 500 divided by the distance squared. This time it's 3 meters, so it's 3 squared, and the answer is 55.5 lux. Street lighting column suspends a 1500 candela light source 6 meters above the ground. We've got to determine its illuminance 3 meters to one side of the lamp base. So here we have a lamp, and our light source will hit the ground here, and we've got to determine 3 meters to one side of it. So this length here is 6 meters, and this here is 3 meters. So what we do have is a right angled triangle, and so we've got to find the cosine of the angle as well as the hypotenuse. So our formula that we're going to use is going to be E equals I divided by h squared times the cosine of the angle. And the two things that we don't know at the moment are h and the cosine, so we have to calculate those individually. And before we can calculate the cosine, we have to calculate the hypotenuse. And the hypotenuse is going to be h equals the square root of 6 squared plus 3 squared. And these are the two values we took from here and here. So when we carry out that calculation, that's going to give us 6.7 meters. So h is 6.7 meters. And now we can calculate the cosine of the angle. Cosine theta equals, it's the adjacent, so it's this side here and this side here. So it's going to be 6 divided by 6.7, and that's going to give us 0.89. So now we have all the values that we need to complete this equation here. And so E equals I divided by h squared times the cosine of the angle. So we have 1500 divided by 6.7 squared times 0.89, and that equals 29.74 lux. So this is our answer. 100 candela is situated 3 meters above a working surface. We're going to calculate the illuminance directly below the light source, and then the question asks what would be the illuminance if the lamp were moved to a position 4 meters from the surface. So it increases the height. So our lamp is here, and it's going to fall on the surface 3 meters, and it's a straightforward calculation. We've got a 900 candela. Our formula is equals I divided by the distance squared, which is equal to 900 divided by 3 squared, and that's going to give us 100 lux. The second part of the question, the distance is increased to 4 meters. Same formula, and this time we have our 900 and we divide it by 4 meters squared this time, and we get 56.25 lux. So there's our answer. What sodium vapor street lamp emits 22,500 candela and is situated 5 meters above the road. We've got to calculate the illuminance directly below the lamp and then at a horizontal distance along the road of 6 meters. So just a diagram to show you what that's going to look like. So we've got a point there at 5 meters, and then we've got another point along the road surface of 6 meters. And so what we've formed here is a right angle triangle Actually, that doesn't look very right angle, does it? It's a little bit better, but not much. So our first calculation is going to be quite simple because we're actually going to, at that point there, and later on calculate this point here. So first calculation for A is equals I over D squared, which is 22,500 divided by 5 squared. And if you put that into your calculator, that's going to give you 900 lux. And then part 2 of the question, we've got to calculate this horizontal part and this cosine of this angle before we can calculate the point here at EB. So our calculation E equals I over h squared times cosine theta, and what we don't know at the moment is this part and this part. So to calculate that, we've got to put the values in. I'll just remind you of the diagram that we've got. We've got a lamp, okay, and it's got a point there, along there. So this point was 6 meters, this point was 5 meters, and the candela was 22,500 candela. And we've got to calculate this cosine as well, but we need to calculate this first, okay, the hypotenuse. And the hypotenuse, using Pythagoras' theorem, is going to be the square root of 5 squared plus 6 squared, and that's going to give us 7.81 meters here. And then we can work out the cosine of the angle, which is going to be the adjacent over the hypotenuse. So this value here is going to be 5 meters divided by 7.81, and that is equal to 0.64. Okay, so we are going to be using these new values in our equation, which I'll remind you is E equals I divided by h squared times the cosine theta, and that's going to equal 22,500 divided by 7.81 squared times 0.64, and when you put that in your calculator you get 236 lux.